Hi, my name is KT with MCS, and today I have a video for you on the Tornado, the process of designing, the process of R&D, and how we prototype the project, and kind of go through the process for you so you can see what it takes to bring a product into reality. So first, before we do any type of project, of course, we kind of talk about it, find out what the futures we're looking for, what we're gonna do to the project before we get started. And then once we have an idea what we want, we put it into a 3D format. Let me show you what we have done and what it takes to actually put a product together. So this is a base drawing of the first version that we did on the Tornado. The Tornado is the X7 conversion kit. It's bringing all the Tickman X7 Classic back into circulation, and to do that, we decided to build it off on an AK version. There's a lot of markers out there. There's SMG, there's AR, but not really true base AK version. So we decided to make it an AK version. So first we built off the AK platform. It has an AK mag release. It has the AK kind of top rail there. But we're not satisfied the way it looks, so we kind of scrapped that and we jumped to the next version. And this one we improved a little better geometry, better design. We added a trigger frame, safety, even dedicated buttstock for it, but still missing some. So we decided that we're gonna make it off of the AK12. So the AK12 has top rail run all the way to the back. We integrate the body with the handguard a lot better. And for the side here, we made it with a lock bolt. The same lock bolt can be used on a Blizzard and a bolt. So kind of 2-in-1 system. Rather than having to make a whole new lock bolt, we decided to kind of integrate that in there. Charging handle, the ambidextrous. You can actually punch out the body and attach your charging handle on both left and right hand side. So once you punch out, that's it. You can't really change your mind afterward. The airline on the original X7 Classic, you still can use that if you still have it. So run right through the ball right here. Once you put our trigger frame on, it will cover that up. So we did, this is the model that we decided to go with, and we did print a 3D production of it, a sample of it right here. So this is how it comes out. The support material, we have not break it down yet to kind of see the actual geometry of it. And the inside here, we have to break this material down so we can put parts inside to do a fitting test and even do a shooting test from it. So you have the left side, right side body, and this is the trigger frame. So you can see the geometry inside already being, the displacement's already there. It's pretty much ready to go. As you just drop in the parts, trigger and the trigger pack, and you can actually shoot this. And I just finished printing this other components over here. This is the handguard for it. This is how it comes out from a printing machine. You can see that I have a safety here that needs to be popped out. This is the handguard for it. This is another handguard of another project. But what we did is, since I made a print, I decided to put multiple components in there at the same time. That way I get more out per print, because each print takes time, and you try and get as many projects in as possible. So once you have this platform that's printed out, you break it apart and you can pull the print off. You see that there support material. This support material helps prevent a collapse during the printing process. What we do is we break it off with a screwdriver or a small mallet. It just comes right off, and the small residual part we put into a bath, and it kind of dissolves the little pieces off, little residue behind, and you have a perfectly good part that you can actually test. So for this handguard, you can see that once we print it out, it's pretty good a production part. Of course, there's still some fine tuning left to do, but this one came out beautiful. See that, how it attach on just like that. So now all we have to do is just break off the material. You can see the outside look. I print this one a little bit different because you don't want to consume too much printing material So for this one, see how the geometry of this one kind of come out? Had we print it this way, you see all the support material have to build from the bottom, and we don't want to use too much material to do that. So we print it this way. That allow it to use minimal material as possible, and that's why it come out this on the outside right inside. And for this one, if we did that the other way around, it doesn't have it's tight now. It doesn't have the outside extruding. That's why we print a flat surface, and this one has that, so we print an upward position. So as we take it out, this is how, not this one, but see how the surface looks like? It's almost like a ready to go production product. But this is very necessary. I mean, designing much easier now because you have the opportunity to test the component, test for fitting, test what it looks, the size, the shape. It gives the design process, I wouldn't say easier, but you get a much better product because you have a chance to kind of feel it, touch it before you actually go to tooling, making molds, making tooling. Once you've done that, it's kind of hard to go back and undo it. It's very expensive and very time consuming. So that's how 3D process printing work. It's each project depends on the complexity of the project. Takes from 1 day to like a few months. On the Tornado, we're at about, I would say about 8 months already because we keep on changing the design. It's done, but then we're not satisfied with the way it looks, the way it feels. We have to go back and kind of make changes on it, get it right. Otherwise, what happens is that we don't want to make a product that it's not ready. It takes time, get it right, make it ready. Right, next video we're gonna do is we're gonna break all the material off, and then we will put it together, and then we'll do a shooting test on it. Thank you for watching.